Today we are going to discuss about the magnet. We have already discussed that there is a magnetic field around a current carrying conductor. Now today we are going to discuss about the magnetic property of a matter. That is, rather we can say that we are going to discuss magnetism and matter. The Earth's magnetism predates human evolution. That means I want to say that before human comes in this Earth, there was magnetism, right? But around 600 BC, it was discovered, or the effect of magnet was first seen. The word magnet is derived from the name of an island in Greece called Magnesia. Magnetite, this is an ore. You can say this is a stone, can attract iron and steel. And that was discovered by the Greek. And when this magnetite stone suspended freely comes to rest along geographical north-south. When this magnetite, the piece of a magnetite stone is suspended from a thread freely, then after some revolving, it will come to rest at the geographic north-south direction. That means it has some directive nature or directive property. Chinese discovered this directive property of the magnetite stone, which is called the natural magnet. This magnetite ore or magnetite stone is called the natural magnet. This natural magnet is also known as black stone, lodestone, leading stone, or kissing stone. It has many names, right? The earlier ships used this magnet or magnetite to assess the direction of the travel. The natural magnets are not strong enough. This magnetite stone or black stone or lodestone is not strong enough. It is not strong magnet. Also, it do not possess any particular shape. But in our practical cases, we need some special shape, special shaped magnet, right? And these things are well known to you because in your previous classes you may have read these things. The man-made magnets are known as artificial magnet. The shape of a natural magnet is normally irregular, but in our practices, in different experiments, in different uses, we want some special shape of the magnet. When ordinary iron piece or its alloys are rubbed with this natural magnet, then they acquire the attractive and directive properties of the magnet, of the magnetite. When iron or its alloys are rubbed with this magnetite or magnetite stone, it acquires the attractive and directive property. This means that iron is magnetized. The magnets produces so are known as the artificial magnet. Right? Magnetism can also be produced by passing current through a coil. Already we have discussed that things, right? Passing currents through a coil wound over a piece of iron or its alloy, right? Generally, a insulating wire wounded over a iron, if we connect the wire with a source of electricity, that is cell, then the iron ore get magnetized and it behaves like a magnet. We have already discussed that a current carrying loop behaves like a magnetic dipole. Already we have discussed. Now we are going to discuss about the material, that is magnetic material, the magnet of a material, right? We do not have to connect to a electric source, and the magnet produced by the current is called the electromagnet. We are not discussing right now. We have previously discussed that electromagnetism. Right now we are going to discuss the magnetism, that is the magnetic property of metals, right? Actually this is called magnet, and that those are called, which are produced by the current, are called the electromagnet, right? Now there is a difference between the magnetic property of matter or magnet and the electromagnet. There is many differences, or many rather utility differences also. Now artificial magnets are more stronger and can be made in many shapes according to our usage. Bar magnet, magnetic needle, U-shaped magnet, etc. are the common shapes which we are going to use, or we rather use frequently. Now these different type of these are the different type of man-made magnets, and now we are going to discuss about the some common properties, rather common things or common known ideas regarding this magnetic material or magnet. Rather we can say this as magnet. Magnet can attract iron, cobalt, nickel and alloys of those materials. First thing is this. Second, we can say it has an directive property. That means if a magnet is suspended from a thread, then it will rest in the north-south direction, rather north-south direction of the geographic north-south direction, right? The tip which points to the geographic north is called the north pole, rather it is called north pole, and the tip which points to the geographic south side is called the, or is known as the south pole of the magnet. The earth behaves as a magnet. Later we have discussed these things elaborately. The earth behaves like behaves as a magnet with the magnetic field pointing approximately from the geographic south to the geographic north. Point out this thing, point out this line, that magnetic field due to earth, magnetic field due to earth's magnetism is from geographic south side to geographic north side, but generally magnetic field due to a magnet starts from north pole, right? It exits from the north pole, from north side, north pole to south pole, magnetic north pole to south pole. But what we have told, that earth's magnetic field is pointing from geographic south to geographic north. That means if we assume earth as a magnet, then that magnet has the north pole on the geographic south side, and that magnet's south pole is at the geographic north pole, near the geographic north pole, right? This has to be remembered. Now north pole of two magnets or south pole of two magnets repels each other when they are brought close together, and conversely north pole of one magnet attracts south pole of another magnet. we have called that like poles repels each other and unlike poles attracts each other. North or south pole of a magnet cannot be separated or cannot be isolated. They are they are always together. That means if there is a north pole, then there will be south pole. You cannot separate north and south pole, isolate. You cannot isolate north pole. You cannot isolate south pole. If a bar magnet is broken, let us say this is a bar magnet. This is north pole, this is south pole. If we just broke this into two parts, you may have assumed that we can separate north pole and south pole. But no. When you will separate these two magnets, these are two separate individual magnets with north pole, south pole. Right? If a bar magnet is broken into two halves, we get two similar bar magnets with weaker properties. With weak properties rather than this magnet. That means we can say magnetic monopole do not exist. Clear? Remember your charge. Remember your charge, electric. There is, you can get positive charge, you can get negative charge. That means electric monopole exists, but monopole, magnetic monopole do not exist. Right? It is possible to make magnets out of iron and its alloys. These are some common things about the magnet.